Space Nuts.
Thanks to our supporters who put a bit of money in the can every week. We've actually got a physical can on my door. So if you're a Space Nuts follower and you want to put a couple of dollars in there to support us, that's what it's for. An easier way for those who aren't, 5 minutes from my place, is to possibly be a patron, become a patron. You can do that through our website, and there are different platforms where you can become a patron: Patreon, Supercast. There are other options as well, and you can find out all about it on our website, spacenutspodcast.com. Although we do have a new URL. Apparently, this is a URL, Fred, that is pretty becoming very popular at the moment. Spacenuts.io. That's even easier than all the other stuff. Spacenuts.io is a new URL you can use to find us if you prefer. I mean, the other one still works as well, but spacenuts.io, and then just click on the supporter button, and that's how you can find out about becoming a patron or a supercaster or anything else. And while you're there, have a look around at our website. It's pretty schmick, pretty good. Now, Fred, let's move on to this discovery, I suppose you'd call it, on Mars. The InSight mission, which has been looking into Mars quakes, has made a few discoveries there, but they've also made what I suppose you'd call a revelation about the core of the red planet.
Yeah, that's right. So you and I almost did a running commentary on InSight when they were trying to get that thermometer down into the ground. You remember they
had to hit it with a hammer or something.
They hit it with a robot arm. That's right, to try and get this thermometer into the ground, which in the end failed. So one of the two main missions of InSight didn't really succeed, which was to get a thermometer, I think something like 2 or 3 meters below the surface, so they could measure the heat flow coming from the interior. I'm sure, knowing what NASA engineers are like, they've improvised at some level, and there are probably results that will come from that in due course. But what we have now is the results from the other major experiment that InSight carries, which is a seismometer. So it's been measuring Mars quakes, and most of what we know about the inside of the Earth, for example, comes from seismometry. It's the way earthquakes shake not just their location, but the seismic waves are transmitted through the rocks of the Earth and bounce off different layers deep down below the Earth's surface. So that's how we know about the mantle, how we know about the metal core that there is, because you get different reflections from all those things. And the same is true with the Mars quakes. And so InSight has, or the scientists, the InSight scientists, have analyzed the seismic signals of, I think it's about 170, I think it's 174 Mars quakes. This is actually just 1 month. So they've got, it's quite it's quite a shaky place. Now, these are quakes that are at much lower levels than the earthquakes that we get on our own planet, but there is enough data in them for them to do this great job of working out where the reflections have taken place, what sort of time delays are involved, and it's allowed scientists now to probe the inside of Mars in a way that we could never do before. And the big surprise is that Mars has a metal core that is huge. It's much bigger than was expected. It's got a radius of 1,830 kilometers. That means it's 3,660 kilometers in diameter, if I'm doing my addition correctly, which is a sizable chunk. It's half the diameter of the planet, basically. It's much, much bigger than was expected. And that is really a surprise. It's what it implies is that the mantle, which is the layer above that, the layer of softish rock, plastic rock, is thinner than was expected. And they now have decided that that mantle is made up of just one layer of rock, unlike the Earth, which has multiple. I think there are basically two layers of the mantle, and I think they're called. Get this, Andrew. I think they're called the upper mantle and the lower mantle. There you go.
Yes, I believe so. I've heard that before.
One's below the other, with the core in the centre. So but it looks as though Mars has just got a single layer of mantle. The extraordinary thing about this seismometry is that you can actually work out what kind of materials are involved here. And so the core itself is molten iron, nickel, and other light elements like sulfur, which gives it actually a lower density, apparently. And that might be one reason why it's bigger than we thought it was, because you can kind of work out some of the internal structure of a planet by having spacecraft in orbit around it. That helps. And I think, but you've got to make assumptions about what the density of the various regions are. So I think people assume that the core was more dense than it was, and that would have explained, would have led to the idea of a smaller core. If the core is lighter, then it's not surprising that it turns out to be larger. So, it's really, it's kind of revolutionized the thinking on the interior of Mars from the science that has been done there. One of the scientists is, and I hope I pronounced this correctly, Katerina Milkovic, who is I beg your pardon, Katerina, a planetary scientist at Curtin University here in Australia, who was involved with the InSight mission, and she's made some comments on the fact that the old ideas. She says the old idea is out of the door. These ideas about the thickness of the layers have really major impact for understanding how processes are happening inside the planet. So we've learned a lot. It's really interesting. Another surprise is the crust. The crust of Mars is actually slightly thinner than was previously estimated. It's in the region. It varies quite a lot, but between 24 and 72 kilometers are the figures that we're reading. So, really great stuff that we now have precision studies about the interior of the planet Mars. It's telling the story about the planet's structure that we really didn't know much about in the past. We had some idea of how thick the crust was, and there was a core, but these findings put a little bit more precision to where the layers are in the interior. That's Katerina again.
Yeah, it's prompting questions in my mind as you explain it all. They've discovered or detected hundreds of quakes on Mars through the InSight mission already. What is the cause? We know the planet does not have tectonics. Yeah. So what's causing the quakes?
Some of it will be meteorites that hit the surface and with a thump, because remember, Mars has got a much thinner atmosphere than the Earth, so there isn't the same kind of atmospheric breaking of a meteorite.
Things come in hot.
There is on the Earth. They come in hot, high speed, land on the ground, there's a thud, makes a small crater. We see that happening, actually. We've seen craters being formed almost on Mars by these things, and that sends a seismic signal. But I think remembering now from the early days of InSight, one of the things that scientists were saying is that there's probably just fairly minor faults in the rock of the landscape, and those faults slip from time to time. A bit like the faults on Earth, but of course the faults on Earth are primarily driven by plate tectonics. Here on Mars, they're just driven by probably long-term cooling of the crust, which is one of the things that we think happens on the Moon as well.
The other question that pops up is that the core of Mars they think is liquid, whereas the Earth's core is solid. Right. The Earth's is two stage. There's a solid core in the middle, but the outer layer liquid exterior.
This is So the reason why we have that on Earth is that the core of the Earth's core is big enough, with when you think of the rest of the planet as well, that the pressure down in the center is very, very high. So even though you've got a high temperature, it's about 7,000 degrees at the center of the Earth, that compression by the layers above it is enough to force it to be solid. And so we have this solid iron nickel core with a liquid iron nickel core around it. And it's actually the dynamo effect of those two that gives us the magnetic field. Mars may not be like that. It might just have a liquid core.
Yeah, so a liquid core on its own just doesn't give them what they need to maintain an atmosphere, and it's that may be part of the issue.
Indeed.
And my final question from all of this is: could some of those Mars quakes be a consequence of something going on with a liquid core, or wouldn't they be related at all?
Yeah, that's a question I don't know the answer to. I would guess not, because I think the quakes, basically to get those readings from the seismometer, you've got to have things that are reflected around and pass through the rock. There may be, it's easy to imagine that at the boundary between the core and the mantle, which is probably a fairly sloshy boundary, it's not just, at one point is liquid metal and a meter above it is soft rock. There will be a zone of differentiation. It's easy to imagine that there will be basically turbulence in that zone. There would be movement which might give rise to Mars quakes. So I don't know the answer to that, Andrew, but it's a good question, and I will try and find out.
Okay, that would be the goop zone, where the liquid,
the goop zone,
the solid, the goop zone. I think that would be what you'd need to call it. Yeah. All right, fascinating findings, and when I read the report, I was almost sort of thinking, no, that can't be right. The core of Mars being so massive, and yet it is, and it's a liquid core as well. It's nearly half the interior of the planet, from what the reports.
Yeah, indeed, that's right. I mean, there is another precedent for this, Andrew, in that Mercury also has a much larger core than anybody expected. It's huge, but that's a much smaller planet as well. And the thinking with that is that core would have been the core of a much bigger planet, so it would have had a much thicker mantle around it. But there was a collision in the early history of the solar system that stripped away the mantle and just left the core with this thin layer of rock around it. So another unusual world.
Indeed, very much so. Yeah, it's good to be able to learn something new about Mars, because as you and I have discussed, we've not really known much about what's going on inside, and now we've got some answers. So yeah, I find it exciting. It's really good, really good.
Yeah, it is.
This is the Space Nuts podcast. You're with Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.